Alright, let's get started. We're going to do Pig Latin. I believe that is the next homework assignment. Let's go down here. As the homework assignment says, convert strings to Pig Latin. The first consonant of each word is moved to the end of the word, and I, A-Y, is added. So, first becomes irst-fay. Words that start with a vowel have hey added to the end instead. For example, apple becomes apple hay. Keep in mind the details of UTF-8 encoding. I'm going to copy this over and put that in our editor so we don't have to reference too much. Open the editor right there. And let's make this big and put this at the top. And now we have our hello world. Let's just print it out to make sure it works. Cargo. Run. Here we go, we have our hello world. So in terms of Pig Latin, right, when I do anything really, especially things I don't know for certain, I always look them up. And Pig Latin, based on Wikipedia, has three main rules. Rule 1 is, for words that begin with consonant sounds, all letters before the initial vowel are placed at the end of the word sequence. Then I is added to them. So that's the same as the rules that we have in the homework assignment. However, they have the second rule that's slightly different. When words begin with consonant clusters, which is multiple consonants that form one sound, the whole sound is added to the end when speaking or writing. And they have examples here, like smile becomes irst-fay. And then they have the third one, which is similar to our rule. For words that begin with vowel sounds, one just adds way or yay or just I to the end of it. And I think for us, we have hey that gets added. There's also some alternative rules, but we don't really care about those, or at least I don't. So we have those three rules, and we have to implement them, seemingly. So go back to our editor. The first thing we need to do is have an example string. So let's call it, does it have to be mutable? I don't think it does. Let's call it example. And let's make it equal to a string from, I'm gonna use the letters, the word that they had there. So pig, smile. The third one I think they had was eat. And then in our homework assignment, they had first and apple. There we go. Apple. So now that we have a string that's filled with words, we have to separate the string into words. And we seemingly do that by seeing the pattern, which is spaces. We have to split them by white space. Okay, splitting by spaces. For word in example, and let's look through our method list to see if we have something. Right here it says split by white space. That seems like it's gonna work. And to verify this, we can do things like print out the word and see if it got split properly. Word. Compile that, let it run. Pig, smile, eat, first, apple. Cool. We have now split our sentence into words, or our large string into words. So the next thing we have to go about doing, at least the way I went about it, is figuring out how to implement these rules, sort of. Let me go back to the wiki. So for the wiki, when we look at these rules again, we see that pig becomes igpay, where we take P, we move it to the end, and we add hey. So we're taking the consonant from the beginning and moving it to the end and adding letters. For the second variation, we see smile becomes irst-fay, where we take SM and move it to the end and add A. So we take the first two consonants and then we add that to the end and then we put A after it. And then the third variation is where we just have a vowel at the beginning of the word and then we add way, or in our case, hey, to the end of the word. And in our homework assignment, we have hyphens between the beginning and end. They don't. Slight difference, not a big deal. We'll get to it. So in order to figure that out, we need to be able to tell whether or not a character is a vowel or a consonant. In my book, I don't know if I'm correct, but you're either a vowel or a consonant. And I know how to check for vowels. That seems much easier. So do create a function. Is vowel C, and we're going to take in a char, pointer to a char, right? And we're going to return a boolean, true or false. So in order to check to see if something is a vowel, we should check it against all of the vowels, and we need to create that. Vowels equals to string from A, E, I, O, U, A, E, I, O, U. And now we have all of our vowels. I also like to add a variable called result and return that. It's part of the way I like to program. So let's create a mutable result. Set it equal to false. And at the very end, we return our result. And then right here in the middle, we check to see if it's a true case. So we do for vowel in vowels dot chars, because if you want to, we use chars because if you want to iterate over a string and you want to look at each character, you have to use dot chars method. And now we can check to see if the char that we passed in is equal to the vowel that we're iterating over. So we can do vowel dot, look through the methods. Here we see an equal. So this is seemingly how we compare two different chars. And then we just pass in our reference, C. So if this is true, what this means is the char that we passed in is a vowel, so we return true, and that we can break out of this loop. So we break out of this loop, and once we break out of the loop, the result is returned. So let's test this out to make sure it works properly. That takes in chars. We have a word here. We can just write a for loop inside. For letter in word dot chars, print line char arrow, and that's going to be the true or false. So letter, and then is vowel, and we pass in a pointer to letter, and that should work. Cool. So here with the apple example, at the last one, we have A is true, P is false, P is false, L is false, and E is true. So that's seemingly doing what we want, is checking to see if the letter that was passed in, the char, is a vowel. And if it is not a vowel, hence the false case, it should be a consonant. So the next step is to count how many consonants are at the beginning of the word. So for example, pig has one, right? Actually, we can go to the wiki and look at it, it's clear here. Pig has one consonant at the very beginning of the word, right? So that one consonant gets moved to the end. Whereas in the second variation, smile has two, and those two get moved to the end. Arguably, if there was three will probably get moved to the end, but I don't see that as an example here. In any case, we have to figure out how many letters beginning of the word start with a consonant. And that we can write a function for. Write it here. Why not? Function consonant count. That should work. And we have a word, which is going to be a pointer to a string, and we're returning, let's say, I-32. Doesn't have to be, but for the sake of argument, I think this is fine. And how do we want to do this? We want to count them. So we have our word that's being passed in. For a letter in word.chars. This is where we do our iteration. We have to count, which means we need a variable for counting. Let's add that here. Let mutable count equal 0. And if the letter is a vowel, so if it is a vowel, we do not want to count it, but if it is not a vowel, then it's a consonant, and that should work. So we pass in our letter, say that if this is equal to false, then our count plus equal 1, right? Else we want to break. And at the end of this function, we want to return our count. And that should work. So what we're doing in here is we have our mutable count. We're iterating over this word that we passed in. We're checking to see if the letters are vowels. If they are not vowels, that means they're consonants. So essentially what this is doing right here is checking to see if the letter is a consonant. If it is, we're adding +1 to our count. If not, we're breaking out of it, which means at the first vowel that we see, we break out of this loop and return the count. And let's see if this works. We already checked to see if this worked, so let's get rid of this. And we can do things like print it to screen, print consonant count, and we pass it in, and we have our word, and we print to screen, and it compiles, and we like that. So pig 1, smile 2, eat 0, first 1, apple 0. That seems correct to me. So now I think we have more or less the tools to start writing the pig Latin function, which is going to be moving things from the beginning of the word to the end of the word and adding a suffix to it. A or hey, right? So let's start that. Function pig underscore Latin. And we're going to take in a word. Yeah, word. Make that a pointer to a string. And we're going to return a string. That sounds appropriate because we have to mutate our word and return the pig Latin version of it. So things we need. We need to know the consonant count. We'll call that the ignore count because I'm calling the ignore count. It can be called whatever you want. Ignore count equals consonant, and I'll pass in the word. So the reason why I'm calling it the ignore count is because I'm creating other variables called the beginning. Beginning. I think I spelled that wrong. How do I spell beginning? Okay, beginning, which is going to be mutable. And ending, which is going to be mutable. And what I'm going to do with these is I am going to append, or not append, push, copy the parts of the string that I need to the respective parts. So for example, let me finish writing this and I can do the example. It's hard for me to type and think at the same time. Ending. String from, and every ending is going to start with a hyphen. So what my plan is, right, given that I have these three variables, is I'm going to iterate over the string. And I already have the ignore count, which is going to tell me how many indexes to ignore before I start copying things to the beginning, which is going to be the beginning string. And while I'm ignoring things, anytime I ignore something, I can just append it to the end, which is already after the hyphen. And then after I create my beginning of the string, create my ending of the string, I can then add the appropriate suffix, which is either a or hey. I should probably get those variables here. let A equal A, let hey equal hey. So to illustrate my point, we can do for word, no, we're going over letters, right? For letters, for letter in word dot chars, because we're going over the characters. What we need to know is the indexes, and in order to know the indexes, we have to use something we used before called enumerate. What enumerate is going to do is going to allow us to have the index of the current character that we're iterating over for the word. So we have like the index, the character at index 0, character at index 1. At least that's how I think of it. But I mean, they are complete chars. So the first char, second char, third char, starting counting at 0. In order to do this, we need to have our syntax correct. So we have our index and our letter, which is a tuple. And you see that got filled in. Index usize, letter char. And we can do things like if the index is less than the ignore count, note that they are two separate types. Index is I32. Sorry. They are two separate types. Index is usize and ignore count is I32. So they have to be converted to the same type. So if index is less than ignore count and we cast it to usize, that should work. We then add our letters that we're ignoring to the end. Ending that, I think we can use push because these are letters. Push seemingly takes a char. Else we put it in the beginning. Beginning dot push letter, and then at the very end, so we have the condition of whether or not we add hey or I at the end of the word, right? And that condition is based on whether or not the word started with a vowel. And if it started with a vowel, that means the ignore count should be 0 because the word doesn't start with any consonants. So if ignore count equals 0, then we can say ending dot push string, because we're pushing a string to it now, not a char, is equal to hey. That's the one we wanted. And else ending dot push string I. And at the very end of this function, we want to return the beginning and ending together. So beginning plus ending. One thing to note, I believe we read this in the string chapter early on, is that the plus operator takes, you have the string, we have the plus operator, but the second variable has to be a pointer to a string and not string capital S. So it has to be small s for it to work, I believe. And now we can start testing some of this out. Say Pig Latin. Pig Latin. Pig Latin word. Hopefully this works. Hey, compiled. So we have pig, which is irst-fay, capital P. Smile, which is irst-fay. Eat, which is eat-hay. First, which is irst-fay. And apple, which is apple-hay. So theoretically, we have what we want. At least in our homework, they had first and apple as their examples. But I really don't like this capital letter. So for this capital letter, it took me a while to figure out how to get rid of it. I can just go through the steps with you. So we're acting on chars, right? So here's the Rust main page in terms of documentation. When you click on documentation, this is what it brings you to. What I went about doing to find what I'm going to find, the, I guess, to lower and how to use it, I searched for char, it brought me to this link. I then clicked on this link, opened it up, and then on the left they have the methods. So if you scroll down, or you can do a control find, because we know exactly what we're looking for, something that says lower. We have is lowercase, not exactly what we want. Check to see if it's lowercase. But we keep going, Here, to lowercase. Lowercase sounds like what we want. If you keep searching, you find other things like make ASCII lowercase and to ASCII lowercase. But I did some searching, some reading, at least in terms of the documentation, and to lowercase is seemingly what we want. And they have examples down here so you can see it in action. They have this C to lowercase, then they have this to string, and they compare it. So this is equal to this. So this is UTF-8 example, and that seemingly has a lowercase form. But there are characters in UTF-8 that do not have lowercase form, like Chinese characters. So this is the character for mountain, Shan. There's no uppercase or lowercase. So when you call the to lowercase on it, it just stays what it is, Shan, and it doesn't change. So this seems safe to use. One thing to note, however, is that they have the to lowercase and they have the to string. We're going to find out why they did that, but in summary, it's because the to lowercase returns this thing that is to lowercase, and that is seemingly a different struct. Alright, so going back here, we have our push, we have our letter, and we know that to lowercase is a thing. So I'm going to play it like this so just you can see the error first. And they have the error, and they said expected a char found a struct to lowercase. Alright, to lowercase, don't want that. We saw in the examples that they had a to string. To string is a string, not a char. So there, we either kind of try to convert this to a char, or we can just change this thing. Instead of pushing a char, we can push a string. And I think we get another error, right? Yeah, so we get another error. They expected a pointer to a string, we gave them a capital string, capital S string. Put a pointer here. Compile, and now we have seemingly what we want. irst-fay, irst-fay, eat hay, irst-fay, apple hay. So these are the letters transformed. Last but not least, let's make it into a large string. So over here, let's create a new string. Let mutable new string equal string new. And we have our Pig Latin words. Let's just erase this and do new string dot push string and pointer, and that's it. Add our Pig Latin word to our new string, and then we need a space between them because we split by spaces, so we should add a space back. Push string, give that a space, and then once you get outside of the for loop, we should print out our new string, and I'm gonna call it results. New string. All right, have that here. Now we can see result irst-fay, irst-fay, eat hay, irst-fay, apple hay. One thing to note is that because we did the spaces afterwards, we now have this trailing space, which you can see it because I highlighted it. I'm not sure how well you can see it, but that is sort of annoying. One thing I was able to find was a dot trim. Yeah, let me just go through the steps to find that because that was kind of annoying as well. So this is the documentation page. Same technique. Look for string, see the string, open it up in a new link. See that this is a very large page, so it should have all the methods in it. And then find, when you're talking about white space and getting it out of a string, you're talking about trimming. So you can look for things like trim, but they have this methods on the side, so we can just scroll down here. Right? I saw nothing here. Keep going, and we have some things called trim. We have trim, trim end, trim left, trim right. Technically speaking, this is going to be the right of the string, so we can look at trim right. And then we see here that I have a deprecated since 1.33 superseded by trim end. So instead we should use trim end because trim right is deprecated. And what trim end does is return a string slice with trailing white space removed. Okay, that seems like it'll work for us. Click here, dot trim end, enter, and we no longer have that white space at the end. We have our result, we have our string, and with that, we have reached the end of the video. We have successfully written something that converts a string of text into Pig Latin. Hope that was useful, hope that was helpful. Outside of that, peace.